In this video, we're going to take a detailed look at the Extrude and Weave modelling function in Aspire. This tool allows you to extrude cross-sections or 3D components along the centre of one or more vector drive rails. If the vector drive rails cross over each other, then we also have the ability in this function to get the software to adjust the Z heights of the extruded shapes or the components so that we can create the effect of a weave where they overlap. All the shapes you can see on the screen here were created using the Extrude and Weave function. Let's go ahead now and start a new copy of the software and we'll demonstrate what this powerful tool can do. Let's come down and click on the icon to open an existing file, and from the project folder we're going to start with a file called extrudeexample.crv3d and hit the open button. Here you can see I've got a simple set of vectors that I've drawn in Aspire that I'm going to use to help demonstrate the features of the extrude part of this particular function. So we can see clearly what's going on in the 2D and the 3D view. Let's click on the icon here to tile the windows so we have the 2D view on the left and the 3D view on the right. The icon for the Extrude and Weave function is on the Modelling tab. It's the third one under Modelling Tools here. If we click on that, let's start by showing you a simple example. First, you need to select one or more vectors that are going to represent the drive rail for your shape. So in this case, I'm going to click and select this S curve we've got at the top here, and then I'm going to click on the button Use Selection. You'll see that the software highlights that. It shows me arrows which indicate the direction the shape's going to flow, and a green node that shows me the start point for this particular shape. In this case, I'm just going to come down and select one other vector. It has to be an open vector that's going to represent our cross-section that will be extruded along the drive curve. And in this case, I'm just going to take the default values, use vector cross-section, and we'll leave these two checked. I'm going to come down and make sure that the weave is unchecked here. We'll come to that in a later part of the presentation. And you'll see, as with other modelling tools, we have the ability to scale what we create with this to an exact height. So at the moment, I'm just going to let it scale based on the cross-section I've got selected. And then again, as with all the modelling tools, we need to choose how we're going to want our component to combine with the other shapes in the component tree. So we have add, subtract, merge high, merge low. And then we have the option to give it a name. So let's start by just calling the first shape we're going to make here Extrude, and at this point, with that drive rail selected, the button hit where we said use selection, and one cross section picked, I can hit apply. A shape will be created. We can see the preview of that in the 2D view here, and then the shape in the 3D view as that cross section has been extruded along our drive curve there. And now at this point we could either hit close and we'll have created a new component, or we could hit start new component if we wanted to stay in the function and continue to make new shapes after that. Here let's just go ahead and hit close, and we'll see that shape we've created. It's now been added to the 2D view as a grayscale. We can see the component in the 3D view, and it's also been added to the component tree here. I'm going to select my component and hit the delete key in order to delete that. We'll come back up and click on the extrude icon again. I'm going to reselect my S curve and click on the use selection button. This time I'm going to take the same cross section, click on it, but instead of creating our shape, I'm going to click on the start point here of the drive curve, and I can see that the software has assigned that cross section to both ends of my curve. If I hit apply, then I get exactly the same shape as I had before, and that's what the software does by default if I just have a single cross section selected. What I can do now though is change one of these cross sections or add additional ones in the middle of the shape. So if I wanted to select this rectangle here and then click on the end, it'll replace that. It's indicated to me by the fact that I have a red node here and a red node on this cross section, and a yellow node here and a yellow node on this cross section. What I need to do is hit apply in order for the software to take into account that new shape and to show me what my component's going to look like as it extrudes between the round cross section on this end and the rectangular cross section on the other. If we rotate that around, you should be able to see that in the 3D view. There's my rectangle. On the other end we have the round cross section. Now we can see that because this cross section is wider, that the software takes that into account, and that my shape has also got wider as it's been extruded along the S-curve. So if we wanted, we can actually take another cross section here, could click one of these, click on here and hit apply, and now we can see that the software is going to go between the round cross section to the pyramid, or the angular cross section we've got here, and then to the rectangle at the end there. So if we look at that in the 3D, we can still see we end up at a rectangle, got the pyramid in the middle there, we've got the round cross section at the beginning of our shape. We could also move these once we've put them in place as well. So I could click on this and drag it, hit apply again in order to change the way the shape is being extruded. We can even take the one on the end and shorten the shape by dragging that along and hitting apply. And there you can see now that the shape just ends when it gets to the last cross section that we've put into place. If we wanted to, we could click and drag that back to its end position there. I could even come in and I could right mouse click over a cross section, choose the option to delete cross section. If I hit apply, we'll have gone back now to a shape that goes all the way from the start and end between our half round and our rectangle. There are other options under the right mouse click menu depending whether you click over a cross section. If we right mouse click there, you can see we can adjust the smoothness of the shape, delete as we just did there, or add to all rail nodes that we'll look at in a moment. If I right mouse click over the middle of the shape, then we have options to reverse it, or to insert start points, or to remove all cross sections. If we reverse the rails, let's click on that and hit apply, then what the software's done is change the order of the shape. So now it's going from the start at this end to the end here, and it's moved the cross sections, so the round cross section is still on the start of the shape, but the shape just happens to flow from right to left now, as we can see by the arrowheads in here. If I right mouse click and click on reverse rail again and hit apply, then we can see that that's going to change again. If we had the same asymmetrical cross section going along the shape, then that option would actually reverse the direction of the shape left to right. Let's give you an example of that. We can right mouse click here and choose remove all cross sections. Now I'm going to select the angular one here, click to add that, we'll hit apply, and you can see if we look at that from the top that it's got the large slope coming up from the left hand side here. If I was to right mouse click and reverse rails and hit apply, now we're going to have the large slope coming from the right hand, or the bottom part of our rail here, because it's reversed the direction of the curve, and therefore it's reversed the orientation that we had those two cross sections flowing along our drive rail. Now let's just right mouse click on here again, choose the option to reverse rail once more, hit apply, and now I'm going to select this cross section, which is a mirrored version of this triangle here, and I'm going to click to replace the cross section on this end with that one. So we can see the red node associated with this one, the yellow node here associated with this one. Now if I hit apply and we look down the z-axis, we can see the shape we get as we extrude between those two mirrored triangles. I'm just going to zoom in the 2D view here, and we can see that as the shape extrudes along our curve, that what the software is doing is it's going from this flat edge here to this flat edge on this shape here, and then it's going from this steep flat edge to the more shallow flat edge here, and that's why we're getting this peak traversing along the shape in the S-curve, as we can see here. And the reason that the software is doing this is because we have the option to sweep between spans checked. So that means it's going to sweep between each of the spans in between the nodes on our cross sections. The software can only do that if they have the same number of spans, which these two cross sections do. If we come over and switch that option off and hit apply, then you can see that now it's just going to linearly transition between those shapes without trying to join up the spans. So the point is just coming along in roughly the same position and just transitioning slowly into a flat shape here, and then the same on the other side. So it creates quite a different shape for us. If I go back, click on Sweep Between Spans again and hit Apply, then we go back so it's sweeping between each of the flat surfaces, in this case, of each of my cross sections. Let's just click back in the 2D view, hit F to fit the window again. And if I add an additional cross section in here, so if I select the rectangle, click and add that in the middle of the shape, you can see immediately these numbers appear. If we've got cross sections that don't have the same number of spans, then the software will display how many spans each one of the vectors has. That just gives me the ability to check that. If I go ahead and right mouse click and delete that cross section, you can see it's now not displaying the numbers because these have an equal number of spans. If we have shapes that don't have the same number of spans in them, then the software will do its best to sweep between spans if there are coincident cross sections that have the same number of spans, but it won't be able to do it where it's sweeping between two cross sections that have a different number of spans in them. Although this is relatively technical to understand, an easy way to think of it is if you haven't got the shape you expected, just to try checking the sweep between spans on or off before you hit apply again to see if the alternate version would give you what you were looking for. If we're in the middle of creating a shape, as we are here, then we can make edits to the shapes we're working on. If we click in the 2D view and I hit N on the keyboard to go into node editing mode, and I can actually come into the vectors that I've got here and I can make changes to them. So here, might want to bend this, might want to grab this and go ahead and drag the node up there. I could hit I on the keyboard to input another node, could grab on the midpoint there. We can make any changes we want to this, then come back up, click on the option to reselect rails, and as long as we haven't deleted or changed any of the number of vectors we've got, the software will reselect them. I can hit apply and I can actually make instant changes to the shapes I'm working with. In this case, if I go ahead and grab this shape and add it in here and hit apply, we should see that because I've introduced quite a sharp corner into here, I'm now starting to create a discontinuity in the shape. What we've got there is not a very pleasant looking shape, but that's because this is too wide for it to go around that corner without overlapping on itself. If we imagine those spines coming around there, then they're going to overlap, and that's the shape you can see here. So you do need to be aware of that with the drive curves to make sure there's enough space for your cross sections to fit. As we're creating shapes here, we may want to either reset the current shape so that we're not going to create a component, so we could hit reset here if we wanted to get rid of that, and that would leave the drive rail and the different cross sections selected. Or if I wanted to stay in the Extrude and Weave function and completely clear my selection, then I would come up and click on the Clear Rails button, and that would deselect everything, so I no longer had a drive curve or any cross sections selected. And if I wanted to now, I could go ahead, make changes to these again and use the node editing, and then come back in and reselect the curve, click on the Use Selection button, reselect my cross section and create a new shape. If I hit Clear Rails when I also have a component being created, then it will also eliminate the component as well as also deselecting everything. Now all the examples we've looked at so far have been with an open rail. I'm just going to come down and hit Close now. I'm actually going to come up, say Edit, Undo Node Editing, and I'm going to use Ctrl Z on the keyboard to undo the edits that I made to the nodes to get back to our original vectors. If you wanted to, you could just reopen the file if you've been making edits and you're not able to undo them. Now I'm going to come down and select this vector. Let's click on the extrude icon, click on the Use Selection button, and now we're working with a closed vector shape. If I select cross section again and we just hit apply, then once more it's going to create a shape for us as best as it can with the drive curve we've got and the single cross section that we've got selected. Now at the moment we have the option to create square corners checked, and so we're creating these mitre corners on our shape at each of the 90-degree bends. If I uncheck that and hit apply, then we're just going to have the software extrude the shape around each of those corners, and that'll give me radiused outside edges. So create square corners, will give me the mitre corners. If I uncheck that, then I'm going to get these rounded corners, as you can see here. Let's click on that to go back to create square corners. As we did with the open vector, we can place cross sections anywhere we want along our closed vector. If I hit reset here, make sure we've got our round cross section selected and click on it here, then I can add it on that corner. And if I wanted to, I could add it on all the nodes that we've got within the drive rail. I could right mouse click on the cross section itself and choose the option to add to all rail nodes. See, that's now been placed at all the corners there. We can apply, we'll see a similar shape as that we had before, but now if I wanted, I could make changes to this. We could move those around, or I could come in and I could actually select a different cross section and click on here to change that and hit apply in order to create a different shape. And these can be moved around. We can click and drag in order to change their positions and therefore change the shape that we're going to get. The only cross section that I can't easily replace here is the one that's at the start point of this vector, and that's because the way that we create a closed shape is to have a cross section in effect at the start and the end. So if I wanted to change this cross section to be something different, then the best way to do that would be to hit to clear rails and then to go ahead and just select the cross section I wanted to use for that and add that into that position to start with. So for instance, I might come into here, select my drive rail, click on the Use Selection button. I can see where the start point is, so I've selected the cross section I wanted to go on the start point, and then I could go ahead and just click and add in what other cross sections I wanted to use in the other corners here and hit apply, and now you can see we're still extruding between those shapes. So say though, you can't really replace the cross section on the start point though, so if you do need to change that, then the best thing to do is always to clear your selection completely and start again by selecting your drive rail and going from there. Let's select the oval vector now. Click on the Use Selection button. We'll click on this cross section and just hit apply to see the shape that that creates. Let me zoom in. Again, we can see if we right mouse click on our drive rail and choose the reverse rail options, then that's going to swap the shape around when we hit apply, because it's going to make the shape extrude in the opposite direction, and therefore our cross section will be hung in the opposite direction. If we wanted to see that, we could click to add the cross section there, and then when I right mouse click in reverse, you can see that the red node is put into the opposite side, and that's where this particular part of my cross section is going to be located. So if we hit apply again, we can see how that part will look once we've re-reversed it. So we can see that this shallow angle is on the inside of the part, which is what we'd expect by the orientation we're being shown here. Now there are various other things I can do with the right mouse click menu. If I right mouse click over part of the curve here, then it gives me the option to insert a start point. We've seen how we can remove all cross sections, and also if I'm over a node on here, you can see that the cursor changes and displays a little crosshair there as I move around and go over the nodes on my drive rail. And if I'm over that point, then it would give me the option to make that the start point of my curve. If we click on that, it's going to change the location of the start point. In this case, that won't change the shape we're making, but it might do if we had other cross sections hung on this. So here we could hang that one, put that one on the top and the bottom, put this same one over here, hit apply, and now we're going to get a shape that goes between our angular shape and our rounded shapes at the top and the bottom there. So we have a lot of control over how we create shapes using this particular function. Now so far everything we've looked at has involved taking a vector cross section and extruding it along a vector drive rail. It's also possible with the Extrude and Weave function though to take a 3D component and extrude that along our drive rail. So I'm going to go ahead now and click on the clear rails option again. I'm actually going to close out of the function. I'm going to come up and click on the icon to import a component or 3D model, and from the project folder I'm going to select a piece of clip art which is called Grape Leaf and hit open. With that selected, I'm going to hit the F9 on the key on the keyboard in order to center that, and then I'm just going to scale that down. I'm going to make it height 1.5 inches, hit apply, close, and then I'm also going to rotate that around. So I'm going to click Rotate Selected Objects, and I'm going to enter an angle of 90 degrees and hit Apply and Close, and that will become apparent as to why I've done that in a moment. Now I'm going to go back into the Extrude function. I'm going to select our drive curve up here, click on the Use Selection option, and now instead of using a vector cross section, I'm going to choose the option here to use a component. What I'll be able to do then is select my component from this list here. I only have one component, so there's only one to select. Within the Extrude and Weave function, you cannot pick the components from the 2D view. We use the 2D view for picking things like the drive rails and the cross sections, so you have to use this drop down list here in order to choose the component you're going to use if that's what you're planning to extrude along your curve. I'm going to choose the option here to fill with multiple copies, and to start with I'm going to set the overlap down to 0 and hit Apply. We'll see that what the software does is take that component and is just extruding it along our curve there. Because we've got 0 overlap, I've just got the end of one meeting the back of another. Now you can see the reason that I rotated this around so that it's facing to the right is because that's how the software will look at the component in order to orient it along the curve. It effectively looks at the component left to right in the 2D view here, and then that is the direction that's going to flow along whatever curve or closed shape that you've got selected. Now if we change the overlap so that maybe we'll go to about 30% and hit Apply, then we can see that now we've got the shapes starting to overlap with each other and they're sort of blending together at this point. We could help this out if we wanted. I could hit Clear Rails, hit Close, select my leaf, go to the Properties, and I could select Tilt, click on Set Anchor, and I'm going to click on the left hand side and then go to the right hand side, and we'll add about 5 degrees to that in order to create a wedge shape underneath it so that it's tilted up. Now hopefully when I overlap it, this top end here will overlap with the back end here. Let's just make sure we've got enough distance there. Hit Close, go back to the ISO view, back up, click on Extrude, select the curve, use selection, use component, having the grape leaf is selected at the moment. We still have fill with multiple copies, 30% overlap, so if we hit Apply, now we can see, if we look at that closely, that with the tilt we're creating this rather nice effect of these overlapping leaves flowing along that open curve that we've got selected there. If we wanted, we also have an option here to flip alternate copies. Let me just reduce the overlap a little so we can see this more clearly. And now I'm going to say flip alternate copies, hit Apply, and what's going to happen is every other copy is going to be flipped over. So you can see this one is facing slightly to the left, this one is facing slightly to the right. And we could make this appear more extreme as well if we wanted to. If I hit Clear Rails and Close, you might take the shape we've created there, just rotate it around to give it more of an angle. Now if we come into here, we can click on Extrude, choose the curve, click on Use Selection, choose the Use Component option. You can see we have Flip Alternate Copies checked here. Just increase the overlap a little again there, hit Apply, and now we can see that more clearly how these leaves are being flipped in direction as they're extruded along the curve there. We go ahead and just hit Clear Rails again and show you what happens on closed curves. If I've got a rectangle selected and I'm extruding a component along it, let's click on Use Selection there. I'm going to turn off the flip and hit Apply. You're going to see that it's going to get quite distorted as it goes around the corners. So not all components and all shapes will be compatible to give you a good result. In this case we might get an okay result though if we hit Clear Rails again and use the oval, use selection and hit Apply, because that's a smoother shape and we should see less distortion as the leaf is extruded around there. Again, we might want to try flipping that in order to see what that gives us, and there we can see we've created quite a nice overlapping set of leaves. We might want to increase the overlap to reduce some of the gaps there, and that's created quite an attractive leaf border. Just zoom in to see that more clearly. So this is a very, very powerful function. We're still using the same function that we use to extrude all those different vector cross sections along our drive curves. In addition, we can actually use multiple drive curves as well, which we'll see in a moment when we start to look at some of the options we've got in here for getting the shapes to weave. At this point, what I'm going to do is just hit close. You can see that will create a new component for me, which is represented by all those individual leaves. This is not a group, this is just a single component, so I could not get back to the individual constituent parts of that particular set of leaves in this case. And here I'm going to go up, hit File and Close. I'm not going to save the changes to this. I'm going to hit Open an existing file, and now from the project folder I'm going to choose Weave Example.crv3d and hit Open. And here we've got some different sets of vectors so that we can demonstrate the weave part of the Extrude and Weave function. So let's click on the icon to tile the windows so we can see the 2D and 3D view. Come down to the Modeling tab, click on the Extrude icon, and this time I'm going to select 4 vectors. So you can see we've got 4 individual straight lines here. I'm just going to drag a box around those and click on the button to use selection. Now if I select the rectangular cross section at the top here and just hit apply, then we get that shape extruded along each one of those vectors, and we see a result pretty much as we'd expect from having looked at this in the earlier part of this example. Now we also have the option though that where the vectors overlap, we can get the software to give the effect of it weaving by raising the shape up and down where each part crosses over. If we switch on the weave under and over at crossings, at the moment I have set to scale shape Z under 100, Z over 100. If I hit apply, in this case I don't see any difference because it's scaling it to 100% of its current height, no matter whether it's overlapping and we want it to look like it's going under, or whether it's overlapping and we want it to look like it's going over. If I want to change this, then I can come to Z under, I could enter 50%, hit apply, and now what the software is going to do is reduce the height of our cross section as it's extruded on the areas where it overlaps by half of its original distance. So there you can see that the top is level, but these areas are all going down. If we change that back to 100% and hit apply, it'll go back to as it was before. And what I could do now is change the Z over, so that is set to 150%, hit apply. And now we can see instead of it going under at these places, it's actually raising up in the other locations, again by 50% of the original height of that particular cross section. And we could do that simultaneously. I could go 50% under and 50% over, and now we've got the effect of it going up and down into those areas where each of those vectors crosses over. Now if we go ahead and change the shape, so let's pick the round shape here and hit apply, we can see now that our 50% over and 50% under is not too bad, but we're starting to get these to kind of dig into each other a little bit, and we're either going to have to drastically reduce these values or increase these values in order to make sure that we see straight lines in between each of those cross-section overlaps there. If we change that cross-section again and hit apply, now we can see it's making quite a big difference to the shape. It's actually squashing that down quite a lot there and raising it up quite a lot here. So we're still getting the effect of a weave, but we're losing some of the consistency of our original cross-sectional shape. That's where we have the other option here to add base instead of scale shape. This is just scaling the original shape. The add base option, if we choose that, will either raise the whole profile up by just adding material underneath it, kind of like adding a base height to a component. So here if we set that so that when it goes under we don't want to add any material, we just want the original cross section, and when it goes over we want to add 100% of the original height but just as a vertical edge, then I'm going to hit apply, and now we can see we get a much more consistent cross section because that's not changing, but all the software is doing is either raising the part up or lowering the part down in order to give us the weave effect. Generally speaking, when we use the add base option, that is going to give us a finished model that will have a higher Z height than using the scale shape option. But for some applications, that's just the right one to use in order to maintain this consistency. If you're not sure, you can easily switch between these and they will remember the values that you associated with each one because they tend to be quite different. Typically for add base you may go between 0 and 100, 0 and 50, something like that. And for scale shape you may just slightly modify it to come a little below 100 or a little above 100 depending on the effect you're looking for. Even though we're now creating a weave, we can still access the other parts of the function. For instance, we could take that cross section we've got selected there, click to assign it to the rails, and then I could come up, select this cross section, and we could click that end, and then I might select this cross section and click that end and that end. So now what we're going to do is sweep this cross section horizontally, and we're going to have the round cross section down here and then the rectangular cross section down here. Let's just click to make sure we're still on the add base option and hit apply. And then we can see the result of that now in the 3D view. I could even go between different cross sections if I wanted, so we could click here and I could add that into there and hit apply, and now that's going between the round to the more shaped one to the round one again. So very, very powerful function that you've got here to create these extruded shapes and then be able to weave them together. Let's go ahead now and just close out of the function here. We can see there's our single component that we've created, and now I'm just going to hit delete on the keyboard. Something else that could be important is the order that the shapes are weaved in, as in which parts go up and which parts go down. You can control this by reversing the first drive rail that you select. In order to do that, you need to make sure that you have actually selected a single drive rail like this first and then selected the others. The order doesn't matter that you select the others in at the moment. So we know that this is our first drive rail here. As such, if we go into the Extrude and Weave function, click Use Selection, I'm going to select the cross section here, we'll hit Apply, and we can see at the moment this is going over and this is going under, and this is going under and this is going over here. If I come back to the first drive rail, right mouse click and choose the option to reverse rail and hit apply, then we can see that the order of the weave changes. So by reversing just the first drive rail, then that's going to change the order because the software looks along the first drive rail in order to find the first crossover point here to decide how it's then going to go ahead and orient and weave all the other areas that the lines are overlapping. Now in this case we've used a fairly simple set of 4 lines, but you can extrapolate to see how if you had a full grid of straight lines crossing over each other, either horizontally and vertically or diagonally at an angle, how you could use these with simple cross sections in order to create a basket weave pattern. What I'm going to do now is go ahead and close the Extrude and Weave function. I'm going to delete that component and we're going to go on a different layer that has a different set of vectors on, just to look at how this works with a slightly more complex set of overlaps. So I'm going to click on the Layers tab, switch off the Simple Weave layer, switch on the Circle Weave layer and click on the name there to make that active. Go back and click on the Modeling tab, and this pattern here has just been created by taking a single circle and copying it and mirroring it about the center of the part, and that gives us this overlapping pattern that you can see here. So we can select our 4 closed vectors here, click on the icon to Extrude and Weave, click on the button to use selection, and then again with the option selected to use vector cross section and weave, we could just click on one of the cross sections and hit apply if we wanted to generate a shape. And you can see how the software resolves where each of the vectors overlaps in order to create this up and down weave effect. If we wanted to, we could use different cross sections for different circles. Or we could take the cross section we have currently selected, click to apply that to all our circles, and then perhaps choose this curved one, click on it to apply to this top circle here and this circle here. Again, we can hit apply, and now we can see we have a different result based on the cross sections that we've got assigned to the different vector drive rails. Now, as well as using the vector cross sections to extrude along curves to do the weave, we can also use the components as well. I'm going to just click on clear rails here and hit close in order to exit out of the function. I'm going to come up and click on import a component or 3D model, and from the project folder I'm going to select a 3D clip file called weave-group and hit open. So we can see, if we take a look at the component tree here, that there's just a couple of components that have been grouped together in order to create our shape. If we zoom into the 3D view, we can see what it looks like. It's just a little flower head on top of a extruded shape underneath there. What we're going to do is select our 4 circles again, go into the Extrude and Weave function, click on the Use Selection button, and we're going to use the option to use a component this time. We can see we only have one in the list. We have our component group in the list there, and I'm going to say fill with multiple copies, and I'm going to set this to overlap 10%, going to uncheck flip alternate copies and go ahead and hit apply. Now we can see the shape that has created for us. We can see that it's copying our component around there. We've got a slight overlap, so we get a seamless shape, and it's still also weaving up and down based on the settings that we've got specified here. If we wanted to, we could make the overlap larger so that the flowers in the model start to overlap and create a slightly different effect. We'll go up to around 40%. And so you can see what we're creating there is an extremely complex shape just by using a fairly simple component and the Extrude and Weave tool in order to extrude it around each of these curves, but also set it so that it raises the Z up and down in the areas where they overlap. Now, to finish, I'd like to show you an example where we examine the stretch to drive rail length option with another component and a different set of curves. So let's click on the button to clear rails. I'm going to close out of the function, select the component we imported and delete it. Then I'm going to come down to the Layers tab. I'm going to switch off the Circle Weave layer, switch on the Stretch Weave layer, select it so that it's active, click back on the Modeling tab, choose the Import Component or 3D Model. We'll select the Paintbrush file from the project folder here. This is another piece of the clip art that comes with the software. I'm going to rotate that 90 degrees so we orient it properly for our extrude function. I'm going to click on it, then just drag and move it up to the top here. And we'll click on the icon to set selected object size and just scale it up a bit. So I'm going to make it width 8, link the X and the Y, hit apply and close. Now I'm going to come over and click on the Extrude and Weave icon again. Go and select this line, click on the Use Selection button, going to uncheck the Weave option, choose the option to use a component, and this time though, instead of fill with multiple copies, we're going to choose the option to stretch to drive rail length. So what that will do is just take a single copy of our component and stretch it to the full length of the line. So if we hit apply, then we can see that that component has actually been distorted along the curve we've got selected there, and that'll work with closed shapes as well as open shapes like this. Now, in addition to taking a single component and a single line like this, we could also click to clear rails. I could select these 2 vectors, click on the Use Selection option, still with Use Component and Stretch to Drive Rail Length selected. I'm going to hit Apply. So now we've got the 2 crossing over, and again still both distorting along those 2 curves, but we can also choose the option to weave. In this case I'm going to choose the option to scale the shape, and we'll set this to be 50 and 150 and hit apply, and there we can see now one is being raised up and the other is being lowered down in order to get the effect we're looking for there. And we could manipulate those percentage values if we wanted to change those. We maybe would come to 75 and then see how that looks. And this would be very powerful if you had something like a snake twisted around a staff, or other components that you want to get to follow a line but also potentially to raise up and down as they overlap. If we were happy with that shape, we could just hit close now, and there we'd have our new component. And it's important to remember that that is just a single component. It is not two components that are grouped together. So the result of the extrude and weave function is always one single component, not a group of components. So that almost concludes our detailed look at the extrude and weave function. You've seen what a powerful and flexible feature this is, and although it's only a single icon, how the shapes you can create with it are very varied. We looked at how we could start by creating something very simple by taking a vector cross section and extruding that along a vector drive rail. We looked at how we could introduce multiple cross sections in order to make a more complex shape, or even use closed drive rails to start to create borders. We also looked at how rather than using a vector cross section, we can import a 3D component and extrude that along our vector drive rails as well, either so it repeats or as an individual object that's stretched all the way along the full length of the line. We finished off by looking how you can take all these shapes a step further by using the weave option in the function. That concludes this video.